what I have is all the stuff on the front side of the notes is going to be a greater than, with our absolute value is going to be greater than something, and all the stuff on the back is going to be our absolute value is less than. So what I want to start out is just a basic definition, and this definition can trade out where it says I have absolute value is greater than or equal to k. You could just do a plain greater than. It would just change the symbol I'm going to use. I just used greater than or equal to in the actual definition, but if it was just a plain greater than, we would just interchange those symbols. Okay, so this one says absolute value of x is greater than or equal to k. Now here's the requirement though. K has to be a positive number. If it's not a positive number, like when we were doing the equation, your absolute value can't be equal to a negative number with an equation, so that would give us like no solution. In this case, with an inequality, it's going to be kind of what I would call a special case. So we'll talk about these in a second. But k is assumed to be a positive number to fit this definition. So this says absolute value of x is greater than or equal to some number k. To get rid of the absolute value here, you are going to do two separate inequalities. So this is going to be, just drop your absolute value. And I just started to write that really weird. So x is, just drop the absolute value, just x, whatever's inside the parenthesis, or inside the absolute value symbol is greater than or equal to k. Or x is, I'm going to flip the sign over, so less than or equal to, and I'm going to make, whatever the number is for k, we're going to make it the opposite of that. And I always remember this is great or. If it's greater than or equal to or greater, it's going to be an or statement, and the two inequalities should point away from each other if you have to put this on a number line. I don't know why that looks so faded there. Okay, now, both of the circles here, like on a graph on a number line, I don't know what k represents, but they would point away from each other, and they're going to exclude like a little gap in the middle, but either they're both going to be filled in or they're both going to be open whenever you do this. Now, let me make it up with a number because I think that sometimes makes more sense to people. So just as an example here, I have absolute value of x greater than or equal to 6. Okay, by the definition there, I can just drop the absolute value. X could be any number 6 or bigger, so like 6, 7, 8, those are all, if I plug those in, for x bigger than 6. Or, and this is the part that I think throws people off a little bit, if my x value was less than or equal to -6. So when I say that, I mean like -7, -8, -9. If we plug any of those in to that original problem, like a -9, that absolute value is going to cancel out the negative, and then it would make that inequality true. So that's on a graph. I'm just going to sketch this real quick. So like, this is not to scale at all, I guarantee that. So I'm going to have 6, any number bigger than 6, so like 7, 8, 9. When you plug it in for that absolute value, that's going to be greater than or equal to 6. On the negative end, if I get -6, -7, -8, if I plug that back into that absolute value inequality, the negative gets canceled out and it's going to be true. Now, if you have to do the interval notation for this, just write this underneath here. If it's an or statement, your interval would have two pieces to it. So on this end, it's going to go from -infinity to -6. Whenever you write an interval, you're going to start with the lowest possible value. So since that arrow goes all the way to the left forever, we're going to start with -infinity. Never has a bracket with an infinity symbol. And then because this one was greater than or equal to, -6 is going to be a possible solution there. So that's why that has a bracket. All right, for the other piece, it would start at 6 and then it goes to the right forever. So that goes to +infinity, and that would cover the rest of the number line. When you do this, you're basically excluding like -5, -4, -3, all those numbers in between there are excluded. Is anybody having a question? That one's so faded. See if this helps a little bit. Okay. Maybe. Okay. We're going to scooch this up. So if you guys actually solve it, it's not going to just have a plain x, right? It's going to be something way more complicated inside the absolute value. But you want the absolute value alone, and then you're going to break it apart into those two inequalities. So whatever's in here, if it was bigger than 3, like 4, 5, 6, we'd be good. If it was less than -3, so like -4, -5, -6, that would also be good because the absolute value would cancel the negative. So we're just going to copy whatever's right here. So 2x minus 5, just drop the absolute value, greater than 3, so numbers bigger than 3, that's what that's going to say. Or exactly copy, just drop the absolute value, just copy that 2x minus 5, don't change that. To get the other side of that though, what we're going to do, we're going to flip the sign over, so this is going to become a less than, and we're going to take and write the opposite of the number we had when we had our absolute value by itself, so this was 3. So this would be -3. Okay, and then I'm just gonna solve both of them at once. I'm just gonna add 5 actually to both of them just real quick. So in that first inequality I wrote, I get 2x is greater than 8. On the other one, I get 2x is less than 2. And then I'm just gonna take and divide both by 2 for both my parts to this. This is an or statement, so one or the other. So if x is bigger than 4, that's going to give you numbers like 4, 5, 6 inside that absolute value. Or if x is less than 1. So that, if we plug in 1 or any number smaller than that, that's going to give us numbers like -4, -5, -6 in our absolute value. So you can plug them in to check if you would like. Now, to put this on a graph, let me just come up here. Let's see, I'm going to put, and you don't have to space this out perfectly. I'm just looking for the numbers go in the right direction. So maybe you do like 4 or 5, and maybe I do 1 and 0 or something. So I know it doesn't have to be perfectly spaced. But numbers greater than 4 should be an open circle and going to the right, or any number that's less than 1. And if you want to just pick a number, plug it into the absolute value to check, you could do that for either one of those parts of that. We're going to exclude the numbers in between, so like 2 and 3, neither one of those would work. And to write the interval, just in case it asks you for that, for this part of the graph, it would be -infinity, and then it stops at 1. Both of those would have parentheses because I got open circles here. The part that points to the right forever, that starts at 4 and goes to positive infinity. So those would be your two intervals there. And I've got one more that's a little bit more complicated. So if you don't have your absolute value alone, I don't have my next inequality here. You want to get the absolute value totally alone before you try to apply that definition. And we want to make sure that it's related to a positive number, because if it's not, then the definition doesn't apply. Okay, so I've got this mess here. We've got 4 times absolute value, 1/2 x plus 3, then a minus 10 outside the absolute value, greater than or equal to 54. What would you do first here if you were trying to get that alone? Plus 10. Perfect. Okay, try to get rid of any addition or subtraction first. Otherwise, you might have fractions you're dealing with, and that can be annoying. Okay, then what do I want to do with the 4? Divide. Do not distribute. I saw some people do that on their quiz. Don't do that. Distribute, don't divide. I mean, divide, don't distribute. I said that backwards. Okay, so we get 1/2 x plus 3 greater than or equal to, that's a nice number, that's 16. Okay, now once you're here, as long as this is a positive number, okay, it doesn't matter what this is. Whatever this is, if it's greater than, it's either going to be bigger than 16 or less than -16. So you're just going to drop your absolute value and just copy that down. So 1/2 x plus 3 greater than or equal to 16. That would give us numbers like 17, 18, 19 if we plug them back in for x, which would make that work. Or just copy it down again, just drop the absolute value, copy it. But to write the other part of that, we're going to have to flip the inequality symbol over. So that's going to say our expression there's going to be less than or equal to, and then the opposite of that number, which is -16. So if we solve that inequality, any value we get for x, it's going to be like -17, -18, -19 when you plug it back in. the absolute value will then cancel the negative and make it a true inequality. So completely up to you guys. I usually just kind of do them both at once. So for both of the inequalities here, I would just subtract 3. We're just going to get different numbers. So I'm going to get 1/2 x is greater than or equal to 13, or 1/2 x is less than or equal to negative 19. How do you guys want to get rid of the 1/2? Oh. Perfect, yeah. I multiply both sides by 2. If you can just flip that fraction over, that's going to be the easiest way to get rid of a fraction, is multiply by its reciprocal. Now that's not flipping any signs over or anything like that, multiplied by a positive number, yeah? So this would be x is greater than or equal to 26, or x is less than or equal to, I think that's negative 38. You guys tell me if that's wrong. Okay, so if we plug in like 26, 27, 28 to our inequality, it's going to give us some number bigger than 16. If we plug in negative 38 to our inequality, or any number smaller than that, it's going to give us like a negative 17, negative 18 if we simplified, and that would satisfy that inequality. Now, if you guys are graphing this, it does not have to be perfect in any way, but the negative 38 should be on the left side, and the 26 should be somewhere on the right side of that, so we're at least going from negative to positive. And then close circle on both of these guys, and they should point away from each other. A greater than or greater than or equal to for this question, they got to point away from each other. Those circles are supposed to be filled in. That wasn't my greatest artistry there. Okay, then for your interval, okay, I'm going to do the one on the left first. This goes to the left forever and stops at the 38. So negative infinity, negative 38. The negative 38 would end up having a bracket because you got that circle filled in. And then the other one is going to start at 26, but it's a filled in circle, so it's 26, and it goes to the right forever, so that would go to positive infinity. So if you're doing interval notation, that's what we would look like. Inequality notation is what I've got with the greater than or less than symbols, and then obviously you guys have the graph. Okay, is anybody having a question? Okay, now, I don't know if you remember this, but at the top of the page I mentioned to you that definition only applies if your absolute value by itself is related to a positive number. So, doesn't matter what's in here. If your absolute value by itself is related to a negative number in an inequality, one of two things can happen. So we're going to do one on this side and one on the other side. Okay, doesn't matter what this number is. When I take an absolute value of something, what does it do to the number? Always makes it positive. Okay, so what I have here is I can spell, I promise. I have some positive number, I don't know what, just going to depend what we would plug in for x. It's saying a positive number is greater than or equal to, in this question, negative 30, but some negative number. Okay, so what do you think about, is that inequality true? Is a positive number always bigger than a negative number? For sure. Some people get thrown off here by the or equal to. It's never going to be equal, but a positive number is always greater than a negative number. The or equal to part, it doesn't have to match that. But a positive number, whatever you plug in for x here, it will always make this true. This is always true. So your solution here would actually be all real numbers, which if you guys remember the interval for that, it's just negative infinity to infinity. And on an actual graph, it would literally be like the whole number line. Every single number that you could think of that you would plug in there for x would always make that a true situation. So anytime you've got an absolute value greater than or equal to either one, a negative number. You can't apply the definition, but it'll always have the same answer. That's always true. Okay. Now we're going to do some less than on the back. All right. So this is extremely similar, and like I told you guys on the front, I did for my definition absolute value of x is less than or equal to k. You could also apply this to just a plain less than symbol. It would just switch out the inequality symbol. It would work for that too. And I remember this, and I call it less than. So when you do a less than with your absolute value inequality, it's going to be an and statement. So we call it less than. So this is going to say absolute value of x is less than or equal to k. Okay. Now, personally, when I do this, I like to do a compound inequality, but I will show you both ways, and you can do whichever one you like better. But remember, if you have an and statement, your solution has to work for both. Okay, so here's how I usually do it. Whatever's in your absolute value, in this case it's just x, I'm going to put that in the middle. All right, and I'm going to have that is less than or equal to whatever that positive number is for k. Remember, it has to be a positive number. And it's going to be greater than or equal to the opposite of that number. So it's got to be between whatever that positive number is and its opposite. And I will show this to you in a second on a graph with a number, so hopefully it'll make more sense. But if you want to, you can actually break this apart into two inequalities and say x is less than or equal to k, but it has to be and x is greater than or equal to the opposite of k. Somebody was asking me this morning if they could do that. The reason I don't usually write it that way is because I can kind of solve it all in one step if I make it into a compound inequality, so I just think that's a teeny tiny bit easier for me personally, but if you want to break it apart, you totally can. Now, if you're doing this correctly, this should be a situation where you're playing connect the dots on your number line. Like if this was my number line, these would both be filled in and they would point together, and it's going to be including just a small little piece, and then the rest of the number line is going to be excluded. So just as an example with numbers, I did absolute value of x is less than or equal to 4. Okay, if you want to use my compound inequality, I just put the smaller number to the left and x in the middle, whatever's inside your absolute value goes in the middle, and then that's going to say it's between -4 and 4. If you want to think about this on a number line, all right, if I got to be less than or equal to 4, right? I'm just going to draw some numbers to the side of this. This is totally not to scale in any way, shape, or form. This is going to be connect the dots between 4 and -4 on the number line. But let me have you think about this. Like if I got to 5 and I plugged in 5, right? Absolute value of 5 is not less than 4. If I get on this end where I've got negative numbers, like if I plug in -6, -6, take your absolute value, cancels the negative, that meant then that I would say 6 is less than or equal to 4. So that's not going to work. So all these numbers outside here would not make the inequality true. Anything between the 4 and -4 is going to work. Now, these ones I actually like way better for the interval notation because I'm just going to grab the two numbers. So it should just be -4, 4. And both of those would have brackets because the -4 and 4 would be included. All right. Now, if you want to do two separate inequalities, you totally can, but I'm going to recommend the compound inequality because it's easier. Okay, so here's how these work. I'm going to get the absolute value all by itself on one side of my inequality symbol. So for this example, I've got 5, and then in my absolute value, x minus 6 plus 3 outside, and then is less than 78. What would you do first if you were going through to solve that absolute value inequality? Yeah. Perfect, all right. Then what do you want to do? Perfect. All right. Don't distribute, divide. This is going to be less than 15. Okay. So if I'm less than, it's going to be an and statement. What I'm going to do is I'm going to just put that, whatever's inside that absolute value, I'm just going to copy that right down, just drop the absolute value, and just on the other side of it, I'm going to put the number that is opposite that 15, so that'd be -15. This is saying x minus 6 has to be greater than -15 and less than 15. So it's going to be in between these two if you're a less than. So outside of that, we'd be at like 16, 17, or negative 16, negative 17, which would then not make our inequality true. Now, to solve this, I'm just going to get x by itself in the middle. So we're just going to add 6 to all the parts of that inequality. So this would be negative 9 less than x less than 21. If you want to write that as an interval super quick, they're both just going to have parentheses. The smaller number goes first, the larger number goes second, same as the inequality symbol. If you're writing a compound inequality properly, the smaller numbers on the left, the larger numbers on the right, and the little arrows, the little small part of the arrow always point to the left. It's saying that x is bigger than 9 but less than 21. And then on a graph, again, you guys don't have to draw, just draw those two critical numbers. If you want to draw a couple other numbers, this is not to scale or anything like that. But just open circle for both here and connect the dots. So any number you can think of between negative 9 and 21, like 0 or 10, any of those numbers will make that inequality true. Any numbers outside that range are going to make it a situation that's not true. Okay, let's try one more here. All I got to do here to get the absolute value alone on this example is just add 7. So we get 2x plus 3 less than or equal to 225. Okay, so I've got absolute value, 2x plus 3, less than or equal to 225. So I'm like, okay, it's less than, so it's an and statement. Less than, the little part points toward my absolute value. So I'm going to drop my absolute value, and I'm going to put that expression in between that number, which is 225, and its opposite. So its opposite would just be negative 225. And we won't have any of these where you guys are dealing with expressions. They will all be an absolute value inequality that is related to a number. So there won't be anything where you have to change or check for extraneous or anything like that here. It's just going to be to solve these inequalities. Now, 2 steps here. What should I do first? Subtract. Don't divide by 2, okay? Because then you have to divide everything by 2, and that's annoying because you would include the 3 in that. So just get rid of any addition or subtraction first. All right, so I got negative, what is that, 228 is less than or equal to 2x, which is less than or equal to 222. Then, my ultimate goal, just get x by itself in the middle. So everybody gets divided by 2. And these should be nice numbers here. This will be negative 114 is less than or equal to x, which is less than or equal to positive 111. So that just means x is between those two numbers. Anything that's bigger than negative 114 at the same time less than 111. And if you want to do the interval here, these would have brackets because I have the or equal to. So that allows negative 114 and positive 111 to be solutions to this. And on a graph, again, you don't have to space these out perfectly. The negative number should be on the left, though, and the positive number should be on the right. And those two numbers are included, and any number in between these two, we're just going to play connect the dots. Is anybody having a question? Okay, now I'm going to do this last one here real quick. This is a special case. So down here at the bottom, again, if you have an absolute value by itself in an inequality, and it's related to a negative number, I just want you to think about it. Do not apply the definition to this if it's related to a negative number, because that definition is only going to work if that number is positive. Okay, so remember from the front, right? Whatever I plug in for x doesn't matter. When I take the absolute value, whatever that is going to be positive, right? This is saying a positive number is less than or equal to negative 11 in my example, but just in general, a negative number. Okay, so that's saying a positive number is less than or equal to a negative number. True or false? That's always false, right? A positive number is always bigger than a negative number. So what do you think the answer would be for this? This is no solution. This is never true, so this is no solution. Is anybody having a question? Okay, I'm pretty sure one of the questions on the homework has a no solution, but I can't remember which one. And then I didn't end up with any examples like this in my notes today because I was really trying to make sure we just had greater than on the front and less than on the back. But if you do divide by a negative, don't forget that will flip the sign over. So if as you're doing the algebra to get your absolute